I am good at using this new technology. Yo. Hey y'all, this is Ciarfox, so welcome to my stream. Bit. We're not starting with that. We're starting with this. Give people a chance to get in here slowly. I'm gonna try and finish eating, because I was gonna eat, but I was having technical problems, and then all the other fun jazz. Anyways. What's cooking? Science is currently cooking. Lots of cooking. All the cooking. So we're back to the subject. Company that started me on this journey of having monthly science you know, when I get the chance to science streams. Intuitive Machine's second lunar lander touches down, but something feels familiar. It fell over again, obviously. Because the other one, it didn't announce it till, like, days later that it didn't land correctly. Which I didn't get on the live stream of me going over it. I don't think. Second time unlucky. A U.S. company's lunar lander appears to have touched down on a wonky angle on Thursday. An embarrassing repeat of its previous mission's less than perfect landing last year. How are you doing, Cake, by the way? The first one was called Odysseus. I didn't mention it by the looks of it. Houston-based Intuitive Machines made history February 2024 as the first private firm to place a spaceship on Earth's nearby neighbor, though the moment was partially marred by the fact that it ended up sideways. But the company's second attempt, it sent its hexagonal Athena lander Vas Mons Molten Plateau closer to the lunar south pole than any mission before it. This was just a few hours ago, if I remember correctly. March 7th. The team targeted a 32 p.m. Eastern Time touchdown, but as time passed, the mission control grew visibly tense. 20 minutes past the scheduled landing time, the company spokesman Josh Marshall announced on a webcast, Athena is on the surface of the moon, but he adds the teams are still analyzing incoming data to determine the lander's status and we're attempting to retrieve an image. You know, I forgot to turn on the slight sound stuff. Sorry, I'm trying to eat and do this at the same time. I know it's not particularly professional of me. Later, CEO Adamus told a press conference, we don't believe we're in the correct altitude. An aeronautical term for orientation. He added that this imperfect positioning could limit the mission due to suboptimal power generation and communications. Don't you love being a publicly traded company? Intuitive Machines' share price tumbled 20% in afternoon trading because you're not allowed to make mistakes. Athena, like its predecessor Odysseus, has a tall cylinder build at 15.6 feet or 4.8 meters giraffe height. Okay, that's a way of picturing it. Its high center of gravity has raised stability concerns. I mean, it's proving that point. Expectations were high after Texas rival Firefly Aerospace successfully landed its Blue Ghost lantern on the moon on Sunday on its first attempt. Cutting-edge technologies. Both missions are part of the U.S. Space Agency's NASA's $2.6 billion commercial lunar payload services (CLPS) program, which aims to leverage private industry to reduce costs and support Artemis, NASA's effort to return astronauts to the moon and eventually reach Mars. It's going so well, can't you tell? Even before Trump was reelected, I've been hearing rumblings from behind the scenes about Artemis having problems. Not that Trump is helping particularly with that end of things, but the mission aims to deploy edge-cutting payloads, including a drill to search for ice, a 4G cellular network test, 3 rovers, and a unique hopping drone named Grace, after the late computer scientist Grace Hopper. It's not clear what can be deployed at this stage. One of Grace's boldest objectives is to hop into a permanently shadowed crater, a place where sunlight is never shown, a first for humanity. Map, the largest of Athena's rovers, roughly the size of a beagle, was to assist in testing a Nokia Bell Labs 4G cellular network, linking it with the Lunar and Grace. The technology designed to one day integrate into astronaut spacesuits. Also aboard Athena is Prime 1, a NASA instrument carrying a drill to search for ice and other chemicals beneath the lunar surface, paired with a spectrometer to analyze its findings. Sticking the landing. Lunar landings are notoriously difficult. The moon's lack of atmosphere rules out parachutes and forces the spacecraft to rely on precise thrusting and navigation over hazardous terrain. Until Intuitive Machines' first mission, the only national space agencies had achieved the feat, with NASA's last landing dating back to Apollo 17 in 1972. The company's first lander, Odysseus, came in too fast, caught a foot on the surface, and toppled over, cutting the mission's short when its solar panels could not generate enough power. This time, the company said it had made critical upgrades, including better cabling for the laser altimeter, which provides altitude and velocity readings to ensure a safe touchdown. Athena launched last Wednesday aboard a SpaceX Falcon 9 rocket, which also carried NASA's Lunar Trailblazer probe, which also faced problems. Ground controls are struggling to reestablish contact with the small satellite, designed to match the moon's water distribution. You know what? Just concentrate on talking. We can do this. Alright. NASA's planning to shut down another piece of Voyager 2. In an effort to conserve Voyager 2's dwindling energy and extend the spacecraft's mission, NASA has shut down another of its instruments. They did it with the plasma spectrometer in October 2024, and it won't be the last. In March, Voyager 2's low-energy charged particle instrument will be powered down. What does this mean for the durable spacecraft? If we don't turn off an instrument on each Voyager now, they'll probably... Hey, Wolfie Wolf! We have only a few more months of power left before we need to declare an end to the mission. Says Suzanne Dodd, Voyager Project Manager, JPL. Things have changed a lot since the pair of Voyager spacecraft were launched in 1997. Our planet is hotter, the human population has ballooned, and Battlestar Galactica came and went twice. I mean, that last part. But the human population is currently having a downturn in some places, too. Voyager 1 and 2 have surprised us all with their longevity. When they were launched, their planned mission length was a mere 5 years. Now, almost 50 years later, 50 years after their launch date, they've both reached interstellar space, a remarkable achievement. Though both spacecraft were proven to be durable, nothing lasts forever, not even plutonium. When they were launched, they both carried about 13.5 kilograms of plutonium-238 in their radioisotope thermoelectric generators. I said that wrong, probably. The RTGs generate electricity by running the heat from the decaying plutonium through a thermocouple. However, as the plutonium decays, the power output is reduced. That necessitates lowering the spacecraft's power demands. That's where NASA is at with both Voyagers. They've had to sequentially shut down systems that are no longer proving to much but scientific benefit. Fortunately, some of the spacecraft's instruments were aimed at planetary science and are less crucial in interstellar space. The Voyagers have been deep space rock stars since launch. Oh, that's the way of putting it. And we want to keep it that way as long as possible, said Dodd. But the electrical power is running low. If we don't turn off an instrument on each Voyager now, they'll probably only have a few more months of power left before we need to declare an end of mission. In October 2024, NASA turned off Voyager 2's plasma spectrometer. On March 24th, NASA will shut down Voyager 2's low energy charged particle instrument, LECP, leaving it only with 3 active instruments: the triaxial flux gate magnetometer, MAG, the cosmic ray subsystem, CRS, and the plasma wave subsystem, PWS. Those 3 instruments will allow Voyager 2 to gather valuable scientific data. Voyager 2's MAG instrument measured the magnetic fields of Uranus and Neptune, and how the solar wind interacted with their magnetospheres. It also played a vital role in determining exactly when Voyager 2 crossed the heliopause into interstellar space. Heliopause is where the sun's gravitation, magnetic and gravitational poles stop. I mean, they don't stop completely, but it's trying to remember how to put it, but I could always just click on the word and it'll show up. Yeah, the theoretical boundary where the sun's solar wind stops by the interstellar medium, where the solar wind's strength is no longer great enough to push back the stellar winds of the surrounding stars. This is the boundary where the interstellar medium and solar wind pressures balance. Anyways, now that the spacecraft is in interstellar space, MAG is measuring the strength of interstellar magnetic fields and how they interact with the sun's magnetic fields. The CRS instrument helps scientists measure energetic particles inside the magnetosphere of the outer planets. It also provided irreplaceable data on the composition, energy, and distribution of cosmic rays. You're tired? We both are tired, yes. I'm tired enough that my mind had a moment where did I explain about the CRS? The CRS instrument helps scientists measure energetic particles inside the magnetosphere of the outer planets. It also provided irreplaceable data on the composition, energy, and distribution of cosmic rays. I am awake. I have been awake since about 1. Help. By measuring cosmic ray nuclei, it helps scientists understand how these rays accelerated and propagated. By measuring the cosmic ray flux... I didn't mean to hit that. 1 second. Alright. I hope I didn't. Ah! Stretch! I'm back! Or am I? By measuring cosmic ray flux in interstellar space, the CRS revealed some details about the ISM. The PWS measured the density of electrons near the solar system's planets. Early in the Voyager missions, the instrument detected light storms on Jupiter and other giant planets. A significant development in understanding these planets. In interstellar space, it's measuring the density of interstellar plasma. Its measurements are critical to understanding the interstellar medium. Throughout its mission, the LECP instruments has told scientists about the energy of charged particles and the dynamics of the sun's solar wind. It also shown how some particles can leak out of the heliosphere into the interstellar space. As Voyager 2 continues its journey into interstellar space, the LECP will tell us more about the heliopause and how particles behave differently in the heliosphere and the interstellar space. Every minute of every day, the Voyagers explore a region where no spacecraft has gone before. Linda Spilker, Voyager's project scientist at JPL. The LECP instrument will be shut down later this month, reducing Voyager to two to only 3 instruments. Nothing illustrates Voyager's longevity and robustness more than the LECP. It's only been shut down because of the energy constraints, not because of degraded performance. Voyager 2 uses a stepped motor to rotate the instrument 330 degrees and provides a 15.7 watt pulse every 192 seconds. During development and testing, the motor was tested to 500,000 steps. And that was enough to see it through until the spacecraft encountered Saturn in August of 1980. However, the motor would have completed more than 8.5 million steps by the time it's deactivated later this month. Like other facets of the Voyager program, the LECP has lasted so long its principal investigator, I am going to slaughter this name. I am sorry, Stamos Kribigis is now 86 years old and is retired into an honorary position. He's now emeritus head of the space exploration sector of the Johns Hopkins Applied Physics Laboratory, APL. Maybe both the man and the instrument will fully retire at the same time. Voyager 1 and Voyager 2 are our first interstellar probes, though they were never intended to be. Everything they're showing us about inner space is a bonus knowledge. Many of the people behind the program are gone now, but both spacecraft live on. There's a poignancy that goes beyond science, charged particles, and the details of interstellar medium. They're humanity's first unintentional envoys into interstellar space, and are starting to outlast their creators. That's a creepy thought. The Voyager spacecraft has far surpassed the original mission to study outer planets, Patrick Cohen, Voyager's program scientist. However, the Voyager are scientific missions. They're still stubbornly fulfilling their missions. Okay, that was a statement we made earlier. Every bit of additional data we gathered since is not only valuable bonus science for the Hilo physics, bleh, but a testament to the exemplary engineering that has gone into the Voyagers, starting nearly 50 years ago and continuing to this day. NASA is determined to milk the Voyager spacecraft for as much data as possible. Once Voyager 2's LECP is turned off later this month, both Voyagers should be able to operate for another year before another instrument will be needed to go dark. For Voyager 1, this means it will lose its LECP. Voyager 2's CRS will be shut off in 2026. NASA engineers say that their power conservation program should lead to both spacecrafts to operate into the 2030s, albeit with a single instrument each. However, they've been operating in deep space for almost 50 years. It's not a benign environment. It's only rational to expect other problems to crop up. It's easy to gloss over the success of the Voyager program now that space missions launch every month. Powerful rovers explore Mars, and a high-resolution cameras deliver a steady stream of yummy images to our hungry browsers. I mean, sometimes they aren't very yummy. It's also easy to forget that they both traveled more than 20 billion kilometers. The fact that, in fact, when Voyager 2 sends us a signal, it takes 19.5 hours to reach us. For Voyager 1, the signal travel time is even greater, 23.5 hours. Those signal times will only grow as the spacecraft continue to their journeys. And every kilometer of their journeys is a new frontier for humanity. Every minute of every day, the Voyagers explore a region where no spacecraft has gone before. Linda Spiker. But it also means every day could be our last. But that day could also bring another interstellar revelation. So we're pulling out all the stops, doing what we can to make sure that Voyager 1 and Voyager 2 continue their trailblazing for the maximum time possible. Euclid discovers is Einstein. I was about to say Justinian, but that's not the right. Not that. In our cosmic backyard. Bad joke! The phenomenon appears to encircle the center of a well-studied elliptical galaxy called NGC 6505, around 590 million light years from Earth. Euclid, an ESA, European Space Agency mission with NASA contribution, has made quite a surprising discovery in our cosmic backyard. A phenomenon called the I was about to say Estinian again. Einstein ring. An Einstein ring is the light from a distant galaxy bending to form a ring. Yeah. A ring that appears aligned with a foreground object. The name honors Albert Einstein, whose general theory of relativity predicts that light will bend and brighten around objects in space. In this way, particularly massive objects like galaxies and galaxy clusters serve as cosmic magnifying glasses, bringing even the more distant objects into view. Scientists call this gravitational lensing. Euclid Archive scientist Bruno Attiri noticed a hint of an Einstein ring among the images from the spacecraft's early testing phase in September 2023. Even from that first observation, I could see it, but after Euclid made more observations of the area, we could see a perfect Einstein ring, Altieri said. For me, with a lifelong interest in gravitational lensing, it was amazing. The ring appears to encircle the center of a well-studied elliptical galaxy called NGC 6505, which is around 590 million light years from the Earth in the constellation Draco. That may sound far, but on the scale of the entire universe, this galaxy is close by. Thanks to Euclid's high resolution instruments, it's the first time that the ring of light surrounding the galaxy has been detected. This is the close-up. Light from a much more distant galaxy, much more distant bright galaxy, some 4.42 billion light years away, creates the ring in the image. Gravity distorted this light as it traveled towards us. This faraway galaxy hasn't been observed before and doesn't yet have a name. An Einstein ring is an example of a strong gravitational lensing, explained Connor O'Roydon of the Max Planck Institute of Astrophysics, Germany, and lead author of the first scientific paper analyzing the ring. Yeah, I know, right? A strong lead author of the first scientific paper analyzing the ring, a strong gravitational lens produces multiple images of a background source that may appear as arcs, forming a ring like this, for example. All strong lenses are special because they're so rare, and they're incredibly useful scientifically. This one is particularly special because it's close to Earth, and the alignment makes it very beautiful. Einstein rings are a rich laboratory for scientists to explore the many mysteries of the universe. For example, an invisible form of matter called dark matter contributes to bending of light into a ring, so this is an indirect way to study dark matter. Einstein rings are also relevant to the expansion of the universe, because the space between us and these galaxies, both in the foreground and background, is stretching. Scientists can also learn about the background of the galaxy itself. I find it very intriguing that this ring was observed within a well-known galaxy, which was first discovered back in 1884, says Valerina Pettorino, ESA's Euclid project scientist. The galaxy has been known to astronomers for a very long time, and yet this ring was never observed before. This demonstrates how powerful Euclid is, finding new things in places we thought we knew well. Yeah, the dark matter to bind them. In the darkness, bind them. Demonstrates how powerful Euclid is, finding new things in places we already knew well. This discovery is very encouraging for the future of the Euclid mission and demonstrates its fantastic capabilities. By exploring how the universe has expanded and formed over its cosmic history, Euclid will reveal more about the role of gravity and the nature of dark energy and dark matter. Dark energy is the mysterious force that appears to be causing the universe's expansion. The Space Telescope will map more than a third of the sky, observing billions of galaxies out of 10 billion light years. Out to 10 billion light years. It's expected to find around 100,000 strong gravitational lenses. Euclid is going to revolutionize the field with all the data we've never had before. Although finding this Einstein ring is an achievement, Euclid must look for a different, less visually obvious type of gravitational lensing called weak lensing to help fulfill its quest to understanding dark energy. In weak lensing, the background galaxies appear only mildly stretched or displaced. To deter this effect, scientists will need to analyze billions of galaxies. Euclid launched from Cape Canaveral, Florida, July 1st, 2023, and began its detailed survey of the sky February 14th, 2024. The Estinian ring found it. The Estinian why did I say Astidian? It's Einstein. I've been playing too much Final Fantasy 14. Einstein rank so early in its mission indicates Euclid is on course to discover many more secrets of the universe. More about Euclid. Euclid is a European mission built and operated by the ESA with contributions from NASA. The Euclid Consortium consists of more than 2,000 scientists from 300 institutions in 15 European countries, the United States, Canada, and Japan. Is responsible for providing the scientific instruments and scientific data analysis. ESA selected Thales Althana Space as prime contractor for the construction of the satellite, and its service module, the Airbus Defence and Space, chosen to develop the payload, including the telescope. Euclid is a medium-class mission in the ESA's Cosmic Vision program. 3 NASA-supported science teams contributed to the Euclid mission, in addition to designing and fabricating the sensor chip electronics for Euclid's near-infrared spectrometer and photometer, NIPS. NASA's Jet Propulsion Laboratory led to the procurement and delivery of the NIPS detectors as well. Those detectors, along with sensor chips electronics, were tested at NASA's Detector Characterization Lab at Goddard Space Flight Center in Greenbelt, Maryland. The Euclid NASA Science Center at IPAC at Caltech in Pasadena, California, will archive the science data and support the U.S.-based science investigation. JPL is a division of Caltech. It was a very fortunate timing. Astronomers watch first black hole to shut off blast back to life. Astronomers have seen a quiet supermassive black hole in a distant galaxy erupt jets of ultra-hot gas, marking the first time a black hole is ever switched on within human lifetimes. The observation also hinted at an unseen star that may have been teetering on the brink of this black hole, but remarkably resisting being swept into the abyss. Studying this doom-defying star could provide long-sought insights into the elusive interactions between the cosmic behemoths and the material in the surrounding gas disks that hold sway over their feeding behavior, researchers say. This particular supermassive black hole, which weighs the equivalent of 1.4 million suns and lurks at the heart of the galaxy, very creative galaxy names. I'm joking to some degree. I know there's a scientific reason why it is, but it's still fun. The 1ES 1927 plus 654 roughly. Yeah, at least 5 pounds, yeah. Roughly 270 million light years from Earth, has kept astronomers hooked for the past several years due to its peculiar behavior after an extended period of quiescence. You know what? One second. Since I am so good at English, and that I'm not. Save me.
Quiescence.
Quiescence. It's lovely knowing how it's... knowing what it means, but unable to say it. Since a mysterious flare-up in 2018, it began steadily emitting X-rays starting in late 2022, signaling to astronomers that yet another powerful but unexplained event was underway. Indeed, soon after, radio emissions from the galaxy, which had been basically non-existent, all of a sudden went up very fast. So fast it was almost suspicious. Alan Meyer, an associate professor of physics at the University of Maryland, Baltimore County, who led the radio observations, said on Monday, January 13th, during an American Astronomical Society press conference. This is unprecedented. We've never been looking at a black hole and watched it go from being radio quiet to suddenly very radio loud, she added. It was very fortunate timing. Images from a network of radio telescopes across the US revealed never before seen jets had turned on, blasting hot blobs of plasma from both sides of the black hole at about 1/3 of the speed of light. While it's unclear what triggered the newborn jets, Meyer and her colleagues suspect that the 2018 flare-up, which itself may have been due to the black hole devouring a nearby star, likely played a key role in contributing to the necessary jet forming material. If that's true, the researchers posit the jets will burn for about 1,000 years on the material from the ingested star before shutting off. These findings are outlined in the paper published Monday, January 13th. You see, this was supposed to be for my February stream. I didn't get because of family stuff. Untold stories. Astronomers have been puzzling over this black hole's behavior since 2018, when it began spewing such intense X-rays that pockets of ultra-hot gas above and below its accretion disk, also known as the black hole coronas, brightened up to 100 times in as little as 8 hours, a telltale sign that the cosmic beast was actively feeding on material from the accreted disk. For reasons still unclear, the spiked radiation dramatically vanished soon after, but began to rebound almost immediately, eventually shining 20 times brighter than before. With such wild radiation swings were unprecedented and had astronomers initially doubting the accuracy of the data. However, when we saw it was real, it was very exciting. Astrophysicist Claudio Ricci, I'm so sorry, I repeat, assistant professor at the Diego Portales University in Chile, said in a statement at the time. But we also have no idea what we're dealing with. No one we've talked to has seen anything like this. A critical puzzle piece came in 2022 when the brightness of the X-ray emissions, which until then had fluctuated randomly, started to rise and fall every 18 minutes. Data from the NICER, which is NICER, and the XMMM Newton space telescopes showed the frequency kept increasing until it reached every 7 minutes, where it has hovered since last year. Pinning down the reason for this continued stability is crucial, researchers say, as it could determine whether the jets themselves are swaying, in which case, however, there's no obvious explanation for why its oscillations would change over time to end up at such high frequency. The more likely scenario, one that scientists understand better terms of the physics involved, is that an orbiting companion lingering very close to the black hole is extraordinarily resisting being consumed. Don't want to be eaten. I can understand that. Because ew. This isn't the same type of war, but still, ew. A hidden companion. The location and frequency of the X-ray signals suggests that any orbiting companion must be within a few million miles of the behemoth's event horizon, which is a boundary which nothing, not even light, can escape. A tiny black hole would dive right into the massive black hole, and its normal star would quickly be torn apart by the behemoth's overwhelming gravitational pull. Instead, only a white dwarf, the dense corpse of a sun-like star, fits the bill, according to Megan Masterson, a PhD candidate at the MIT you'd think that I've heard of these institutes so much and all this other stuff, and I'd be able to say them correctly. Kiev. Yeah, Institute for Astrophysicists and Space Research, and co-author of the upcoming paper exploring the scenario. A white dwarf would be difficult to shred thanks to being extremely compact, and could have already existed in the acceleron disk before moving closer to the black hole, but potentially explaining the increasing frequency of X-ray signals observed by the researchers. Now hovering at the inner edge of the black hole's accretion disk, this stellar remnant might occasionally shed some of its materials, which will effectively give you a bit of extra energy to keep you outside the black hole's event horizon. If a white dwarf is at the root of the black hole's puzzling behavior, the system should be emitting gravitational waves, faint ripples in the fabric of space-time that zip through space at the speed of light. The frequencies of these waves are the sweet spot for detection by the forthcoming Laser Interferometer Space Antenna, or LISA. Like I said, I love what they do to try and make these names work. A gigantic space-based gravitational wave detector that's scheduled to be put in orbit in 2035. Well, let's hope it's still happening by then, but it said 1,000 years, so... Rough estimates of how much mass the white dwarf is shedding suggest it could... Yeah, okay, here it is. Should be able to stick around for quite a while, Masterson says, but who knows. One thing I've learned about this source is we never really know what's going on. Alright. New photos show the volcanic plains of Mercury after a spacecraft flyby. You know, one of the episodes of a while back ago, we talked about how they think Mercury might have diamonds because of just the way it is. I don't remember the exact. Alright. A spacecraft skimmed past Mercury this week, beaming back stunning new images of a surface and showing once again that humanity has a seemingly insatiable longing to understand the universe. 3 things to know! The Bepi Colombo spacecraft flew less than 200 miles from Mercury's surface and photographed volcanic plains and icy craters. It's the 6th time the spacecraft, launched in 2018 by the European Space Agency, has done a flyby. The ESA said in a statement that this was the final gravity assist maneuver needed to allow the 2 orbiters to separate, get into orbit around the planet in late 2026, and to capture even more information. Is Mercury important to us Earthlings? Yes! I didn't completely read this article, but before starting this, but good that it's on my level at this point. There's still so much we don't know about the smallest, somewhat mysterious member of our solar system closest to the sun. What we do know is that Mercury has an unusual composition. Like Earth, it is a metal core, but Mercury's metal core takes up 80% of the planet. As NPR's Joe Palca reports, one of the most intriguing things about Mercury is that despite the blistering temperatures on the sunny parts of the planet, temperatures can reach 800 degrees Fahrenheit, there are places in the craters near the poles which never see the sun. I feel like I'm hearing a lot about space these days. Summertime in the south. Yeah, but I mean, I don't think they have the same amount of water. I would say, I'm looking at this and going, wait, no, this is back in January 10th, so I don't need to talk about this stuff down here. Solar eclipses. Anyways! Hubble captures a supernova hosting galaxy in the constellation of Gemini. Other than the announcement of its discovery in November 2022, SN 2022 AAJN has never been the subject of published research. Why then would Hubble observe the supernova? Is it really called La? Sorry. Okay. Alright. Is known as a type La supernova. It might be because I'm keeping the as blocked that it might actually be messing with the actual thing on this one. Which results from the explosion of the explosion of the core of a dead star. Supernova of this type help astronomers measure the distance to faraway galaxies. It's possible that type La supernova have the same intrinsic luminosity. No matter how bright they are seen from the Earth, they put out the same amount of light as other type La supernova. By comparing the observed brightness to the known intrinsic brightness, researchers can calculate the distance to the supernova and its host galaxy. It's LA or IA. Let me see. Yai. It's 1A. Okay. 1A. Okay. Okay. Why? Why would you use text that didn't make the one look like a one? Well, I didn't realize that you were Googling at the time. I mean, I'm dyslexic, so I need certain texts sometimes just so I know the difference between other texts. Comparing the observed... it seems a simple way of measuring... This seemingly simple way of measuring distances is complicated by cosmic dust. The further away the supernova is, the fainter and redder it will appear. But intergalactic dust can make a supernova appear fainter and redder as well. To understand this complication, researchers will use Hubble to survey a total of 100 1A supernova in 7 wavelength bands, from ultraviolet to near infrared. Oy vey, oy vey, oy vey. This image combines the data taken from 4 infrared wavelengths. Infrared light passes through dust more easily than visible or ultraviolet light. By comparing the brightness of the sampled supernova across different wavelengths, researchers can disentangle the effects of dust and distance and hope to improve measurements of galaxies billions of miles away. So that's what they... that supernova. Alright! International team captures direct high-definition image of the cosmic web! That looks so cool. Anyways. Alright. Matter in intergalactic space is distributed in a vast network of interconnected filamentary structures, collectively referred to as the cosmic web. With hundreds of hours of observation, an international team of researchers have now obtained an unprecedented high-definition image of a cosmic filament inside this web, connecting two active forming galaxies, dating back to when the universe was about 2 billion years old. The real world was... I know, right? A pillar of modern cosmology is the existence of dark matter, which constitutes about 85% of all matter in the universe. Under the influence of gravity, dark matter forms an intricate cosmic web composed of filaments, at whose intersections the brightest galaxies emerge. This cosmic web acts as scaffolding on which all visible structures in the universe are built. Within the filaments, gas flows to fuel star formations in galaxies. Direct observations of fuel supplies of such galaxies would advance our understanding of galaxy formation evolution. However, studying the gas within these cosmic web is incredibly challenging. Intergalactic gas has been detected mainly indirectly through its absorption of light from bright background sources. I mean, you'd see why. But the observed result does not elucidate the distribution of this gas. Even the most abundant element, hydrogen, emits only a faint glow, making it basically impossible for instruments of the previous generation to directly observe such gas. In this new study, an international team led by the researchers of the University of Milano Coco and Bianco include the scientists at the Max Planck Institute for Astrophysicists, obtained an unprecedented high-definition image of a cosmic filament used by MUSE, the multi-unit spectroscopic explorer. Like I said, I love how they try and get these names to work. An innovative spectrograph installed on the Very Large Telescope at the European South Observatory in Chile. Even with the advanced capabilities of the sophisticated instrument, the research group had to carry out one of the most ambitious MUSE observation campaigns ever completed in a single region of the sky, acquiring data over hundreds of hours to detect the filament at a high significance. The image shows diffuse gas, yellow to purple, contained within cosmic filament connecting the two galaxies, the yellow stars, extending across a vast distance of 3 million light years. The study led by David Tronati, a PhD student at the University of Milano Blanco, uses this ultra-sensitive data to produce the sharpest image ever obtained of a cosmic filament spanning 3 million light years and connecting two galaxies, each hosting an active supermassive black hole. The discovery was recently published in the Natural Astronomy. Opens up new avenues to directly constrain gas properties within the intergalactic film. Hello. Welcome in. We're doing the nerdy stuff today. Today's the nerdy stream. Hey, Sabby. Hey, DV. Did it allow the head pat thing? The good stuff. Big sad. I'll fuck with it after, again. By capturing, opens new avenues to direct... We're talking about the actual cosmic web. There is a web! Simulation of a vast region of space based on the current cosmological model and performed using... Is that cool? Discovery recently published in Nature Astronomy opens new avenues to directly constrain gas properties within the intergalactic filaments and refine our understanding of galaxy formation and evolution by capturing the faint light emitted by this filament, which traveled for just under 12 billion years to reach Earth. We were able to precisely characterize its shape, explains to Nori. For the first time, we were able to trace the boundary between gas residing in galaxies and the material contained within the cosmic web through indirect measurements. The researchers took advantage of supercomputer simulations of the universe run at MPA to calculate the predictions of the expected filamentary emission given the current cosmological model. When compared to the novel high-definition image of the cosmic web, we find substantial agreement between the current theory and observations. This discovery and the encouraging agreement with the supercomputer simulations are key to understanding the tenuous gas environment around galaxies and opening the novel possibilities to pinpoint the galaxy's fuel supply. Fabrizio Arrigino Batai. I'm sorry I slaughter names. It's what I do. Alright, have fun. He's from Chile. If I remember. We are thrilled to this direct high-definition observation of a cosmic filament. Oh, it's Bavaria. It's Bavaria. Excuse me. It's Bavaria! It's Bavaria! He's from Bavaria! Those people in Bavaria say, "In Eis kein." One doesn't count. So we are gathering further data to uncover more structures with the ultimate goal of having a comprehensive vision of how gas is distributed and flows the cosmic web. Alright. Bennu! No, don't do this. Okay. We've talked about Bennu for a while. My mouse. Asteroid contains building blocks of life, says scientists. The chemical building blocks of life has been found on the grainy dust of an asteroid called Bennu, an analysis reveals. The samples of the space rock, which were scooped up by a NASA spacecraft and brought to Earth, which, if I remember correctly, this is the one that, you know, we took 6 months to get into. Because we couldn't, get it out of the structure that we put it in. The sample structure. A rich array of minerals and thousands of organic compounds. Those include amino acids, which are the molecules that make up proteins, as well as nucleobases, the fundamental components of DNA. This doesn't mean there was ever life on Bennu, but it supports the theory that asteroids delivered these vital ingredients to Earth when they crashed onto our planet billions of years ago. Scientists think those same compounds could also have been brought to other worlds in our solar system. What we've learned from it is amazing, said Professor Sarah Russell, a cosmic mineralogist from the Natural History Museum in London. It's telling us about our own origins, and it enables us to answer these really big questions about where life began. And who doesn't want to know about how life started? Yep. They had a hard time getting in there. If I remember correctly, yeah. The findings are published in 2 papers in the journals of Nature and Nature Astronomy. Grabbing the grainies. Grabbing a bit of Bennu has been one of the most audacious missions NASA's ever attempted. A spacecraft called Osiris Rex unfurled a robotic arm to collect some of the 500-meter wide space rock before packing it into a capsule and returning it to the Earth in 2023. Yeah, except it took it forever to open that, like 6 months or something, because they sealed it so tightly. About 120 grams of black dust was collected and shared with scientists around the world. This might not sound like much material, but it's proven to be a treasure trove. Every grain is telling us something new about Bennu, said Professor Russell, who's been studying the tiny specks. About a teaspoon full of the asteroid was sent to scientists in the UK. The new research has shown that the space rock is packed full of nitrogen and carbon-rich compounds. These include 14 of the 20 amino acids that life on Earth uses to build proteins, and all 4 of the ring-shaped molecules that make up the DNA. Adenine, glutamine, cysteine, and thymine. No, it's a teaspoon. It's not half a cup. It's a teaspoon. The study also found an array of minerals and salts, suggesting water once was present on the asteroid. Ammonia, which is important for biochemical reactions, was discovered in the sample too. Some of these compounds have been seen in space rocks that have fallen to the Earth, but others haven't been detected until now. It's just incredible how rich it is. It's full of these minerals that we haven't seen before in meteorites. And the combination of them we haven't seen before. It's been such an exciting thing to study, said Professor Russell. This latest study adds to the growing evidence that asteroids brought water and organic material to Earth. The early solar system was really turbulent, and there were millions of asteroids like Bennu flying about, said Dr. Ashley King from the Natural History Museum. The idea is that these bombarded the young Earth, seeding our planet with ingredients and gave us the ocean and made life possible. Yeah, that was in the whole thing. But the they spread it. The scientists. The scientists in the UK got only a teaspoon of that. So they gave it to a whole bunch of people. But yeah, half a cup of dirt altogether. So I guess they sent them out to all the agencies with just a teaspoon. But Earth wasn't the only world getting hit by space rocks. Asteroids would have been colliding with other planets too. Earth is unique in that it's the only place where we found life so far. But we know asteroids were delivering these ingredients, carbon, and water, throughout the solar system. And one of the big things we're trying to understand now is that if you have the right conditions, why do we have life here on Earth? And could we eventually find it somewhere else in our solar system? It's a key question that scientists will continue to try and answer. They have decades of research ahead on the dust brought back from Bennu and the parts of our cosmic neighborhood still to explore. Let's say everybody gets a pinch. You get a pinch. You get a pinch. Alright, scientists produce a particle of light that simultaneously accessed 37 dimensions. It's got to speed by 34. Since we only have 3 dimensions. The Greenberger-Horn-Zellinger paradox, GHZ paradox, describes how quantum theory cannot be described by local realistic descriptions. A new study takes this GHZ paradox to new heights to see just how non-classical the quantum world can get. In this process, their experiments included photons in 37 dimensions, taking the science even further down this strange quantum rabbit hole with the hopes of finding applications in the high-dimensional system. Okay. Classical and quantum mechanics don't really get along in the science of subatomic can get, well, weird. Take, for instance, quantum entanglement, which says the state of one particle can be determined by examining the state of its entangled pair, regardless of the distance. Not as scary as 69, but not as awesome as 69 either, but we knew we were going to get there eventually. This strange fact flies in the face of the classic physics, and even led Albert Einstein to famously describe this quantum quirk as spooky action at a distance. This is what is known as quantum non-locality, where objects are influenced across distances, seemingly beyond the speed of light. Whereas classic physics follows the local theory, the idea that objects are influenced by their immediate surroundings. This is a pretty sharp divide, as explained by the famous no-go theorem known as the Berger, Horn and Zilliger paradox, which essentially details how quantum theory cannot be described by local realistic description. In other words, our brain can't handle the truth. Sorry. Named for the physicists who described the paradox in 1989, the GHZ type paradoxes show that when particles can only be influenced by the proximity they produce mathematical impossibilities. As New Scientist reports, the paradox can be even expressed through the calculation where 1 equals -1. This paradox is useful in showing how quantum properties cannot be described using classical means. But a new paper published in the Journal of Science Advances decided to see just how strange these paradoxes could get. Hey, maybe in a paradox I might have a job. Jokes, quips. Anyways, essentially, an international team of scientists wanted to see how unclassical particles of light could get. And the results may be stranger than the authors originally anticipated. This extremely technical experiment produced photons or particles of light that existed in 37 dimensions. Just as you and I exist in 3 dimensions, plus an additional temporal dimension, these photons require 37 similar reference points. This experiment shows that quantum physics is more non-classical than many of us thought. Technical University of Denmark's Jianzhao Lu, co-author of the Jianzhao Lu. You know, you'd think after playing Hoyoverse games I'd be able to say any of these names correctly. Could be that 100 years after the discovery, we're still only seeing the tip of the iceberg. Pulling this off was no easy thing to do, as Lau and his team needed to feed a version of the GHZ paradox into coherent light, even in color and wavelength, so they could easily manipulate the photons. This essentially resulted in the most non-classical effect in the quantum world to be ever created, says Lau. I don't care. We believe this work has opened several avenues for future research, the authors wrote. We hope that our findings can be used to build even stronger quantum advantages into high-dimensional systems. In other words, if we've only discovered the tip of the iceberg, just imagine what quantum breakthroughs are lurking behind the surface. Me with the cuter avatar beneath the surface. Alright. CNN. It's almost science fiction. Scientists say the shape of the Earth's inner core is changing. Scientists who just months ago... I have a couple things doing with the core and stuff, so... And always remember, science is always changing. It's... as we get more data. So, just stating. Scientists who just months ago confirmed the Earth's core has recently reversed its spin have a new revelation about our planet's deepest secrets. They identified changes in the inner core's shape. Earth's innermost layer is hot, solid ball of metal surrounded by a liquid metal outer core. For decades, planetary scientists suspect that the inner core deformed over time. The solid inner core deformed over time as it spun. Now researchers have found the first evidence of changes taking place over the past 20 years in the shape of the inner core. Signs of the core's deformation appeared in waves from earthquakes strong enough to reach the Earth's center. The research team used the same earthquake data for 2024 study to resolve a long-standing debate over the inner core's rotation. I think we covered it in one of the other monthly things. They found the inner core was once spun faster than the Earth itself. But beginning around 2010, the solid inner core's spin slowed. Now it's revolving backwards, relative to the rest of the planet. Their new study, published Monday in the Journal of Nature Geoscience, builds on that discovery using earthquake data gathered from 1991 to 2023. The scientists' prior work on the core rotation helped them interpret variations in the height of seismic waves, defining them as indicators of changes through the surface of the inner core, says Dr. John Vidal, co-author of the previous study and late author of the new study. We can compare the signals that we see in the inner core is returned to the same position as it was in some other time, and see if there's differences that can't be explained by the rotation. Vidal, Dean Professor of Earth Sciences at the University of Southern California's Dornsife College of Letters, Arts, and Sciences. College of Letters! Good! We learned letters! Sorry, just letters. God, that's so old-fashioned. Shape changes to the core could hold clues about their forces deep inside the Earth that power our magnetosphere. The invisible lines of magnetic energy that protect our planet from solar weather and deadly radiation, the researchers report. Earth evolves on a geological timescale, so observing changes on an annual timescale is always intriguing, as it enhances our understanding of the inner core dynamics, said Dr. Yoshi Miyazaki? I'm having a moment. Associate professor at the Department of Earth and Planetary Sciences at Rutgers University in New Jersey. Previous studies have already discussed how the inner core rotation has changed over the past decade, and this study introduces a new perspective. Non-rotational changes, adding another dimension to the discussion. I believe this will further fuel these debates. Miyazaki, who is not involved with the new research, told CNN. Almost science fiction. Of all the Earth's layers, the inner core is the most remote and mysterious. This solid sphere of iron and nickel is about 70% the size of the moon, with a radius of approximately 795 miles, or 1,221 kilometers. Temperatures in the inner core are as high as 9,800 degrees Fahrenheit, or 5,400 degrees Celsius, and pressures can reach up to 365 gigapascals, more than 3 million times greater than the Earth's average atmospheric pressure on land. While direct observation of the core is impossible, scientists study it by analyzing changes in the size and shape of seismic waves as they pass through the core. Earthquakes generate two types of waves. Primary waves, or P waves, are the first waves produced by a quake, and move the ground in the same direction as the wave is moving. Shear waves, or S waves, are slower than P waves and move the ground perpendicular to the wave's direction. Amplitude changes in the type of core penetrating P waves, PKIKP waves, and the deformations in the inner core's shallowest level. According to the new study, at the boundary where the solid inner core meets the liquid outer core, the sphere's surface might be more malleable than at its deeper levels. It's almost science fiction to visualize what's happening on the surface of the inner core, Vidal said. It's a place so different from our day-to-day lives, with different timescales, different materials, and incredible forces. And yet, we can get down there and learn more about it just by shifting through some of the latest observations. Movement like landslides. Sorry. I'm getting a drink. Scientists analyze 168 paired waves from quakes located in 42 locations near the South Sandwich Islands. Sandwiches. I'm not hungry. A chain of volcanic islands in the South Atlantic Ocean. Tracking the speed and direction of the core's rotation give the researchers a way to detect the changes in the shape of the core. Once they knew the core's rotation speed, they could model its position and compare different PKIKP waves that reached the core as it revolved into the same spot. Amplitude changes in these paired waves could be assigned to the shape changes of the core rather than the rotation changes, according to the study. However, what the deformation of the inner core might look like is harder to pin down. Maybe the topography is going up and down. Maybe it's sloshing like landslides, Vidal said. The most likely thing is that the outer core is just pushing on the inner core and moving it around a bit. While just one inner core location showed signs of deformation in 2004 and 2008, there are maybe more that have been yet to be detected, the researchers reported. It's hard to know if we're looking at an anomalous or a normal location, Vidal said. But one guess would be that some amount of deformation is happening fairly often but in many places. As the Earth's solid inner core spins, the molten outer core turns and sloshes. Their interactions generate magnetic energy, which unspoils to unfold our planet in a magnetosphere. But the liquid outer core is shrinking. Meter by meter, the inner core is siphoning molten metal from the liquid core surrounding it. It likely took billions of years for the inner core to cool and solidify. And over the next billion years, the inner core will continue to cool, slipping drops of liquid metal from the Earth's core until the Earth's inner core is a solid metal sphere, he added. That'll kill the magnetic sphere. There won't be moving iron down there. However, such an event is billions of years in our future. Before that could happen, Earth would likely be obliterated as our sun expands into a red giant. Yay! And swallows the inner planets in the solar system, Vidal said. Until then, scientists should have ample time to investigate the unseen workings of the heart of our planet and discover what the Earth's inner spinning, churning, and shape-shifting might be in store for the planet. Regarding the impact of life, as mentioned in the paper's introduction, the inner core growth plays a critical role in generating the Earth's magnetic field, which protects us from harmful solar radiation. While a direct connection between life on Earth's surface and the ICB, the inner-outer core boundary, remains distant, and what happens at the ICB still has some implications for Earth's long-term evolution. Alright. This is a new one that came out that I found interesting. Sunken continents near the Earth's core could unbalance our magnetic sphere field. Excuse me. The continent-sized structures of mineral protruding from the lower mantle towards the Earth's outer core may be contributing to an instability in our planet's magnetic field. The two odd formations, one under the Pacific and the other beneath Africa, resemble each other in terms of seismic waves, so we're assumed to have the same composition. Cardiff University geodynamicist James Panton, and colleagues have now concluded otherwise, determining the two regions are made of different materials and have different histories. If it is true, it could affect heat flow and convection deep within our planet, in ways that could influence the way the Earth generates its magnetosphere. Up to 900 kilometers, or 560 miles, high and thousands of kilometers wide, the two large, low-velocity provinces have puzzled scientists since they were revealed by seismic data in the 1980s. Researchers have since suggested they're at least in part composed of a former oceanic crust. It's fascinating to see the links between the movements of the plates on the Earth's surface and the structures 3,000 kilometers below our planet. Says University of Oxford seismologist Paula Major Miser? I'm so sorry. I'll repeat for anybody's names I murder here. Millions of years of natural crust is cycling mixed what was once Earth's surface deep into the mantle. The resulting composition now covers up to 30% of the core, slowing the seismic waves geologists use to probe the Earth's inner structure. Our models of the mantle circulation over the past billion years demonstrate large low-velocity providences can naturally develop as a consequence of recycling oceanic crust, writes Panton and team, arguing against competing theories that the anomalies rose from a collision with the Earth some 4.5 billion years ago that led to the moon's formation. The specific structure appears to have 50% more fresh or oceanic crust mixed throughout it than the African province, the researchers found. That makes for a far greater difference in composition between the Pacific province and the surrounding mantle, not to mention a notable difference in its density. We find the Pacific large low velocity province to be enriched in subducted oceanic crust, implying that the Earth's recent subduction history is driving its difference. The notoriously active Pacific Ring of Fire has consistently replenished the crust material this team suspects. In contrast, the region around the African structure is not as geologically active, so the older crust it contains has been more thoroughly mixed in, making this structure less dense. The fact that these two large low-velocity provinces differ in composition, but not in temperature, is key to the story and explains why they appear to be same size seismically. Words are. The different temperatures of these two structures compared to their surrounding regions impact how heat dissipates from the Earth's crust, which in turn affects the convection in the core that drives our planet's magnetic field. The researchers suspect that two mantle structures are not allowing the core's heat to escape evenly on both sides of our planet. They may be contributing to the unbalancing field that maintains our atmosphere's life-supporting qualities. Africa's low velocity providence has already been implicated in the weakening of the magnetic field nearby. The researchers require more data, such as observations from the Earth's gravitational field, to better understand the impacts of this deep Earth asymmetry. Words. They exist. Oh, Wolf, you still here? Wolfie Wolf? Wolfie Wolf, 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 Wolf? Africa's breaking apart. A new ocean is forming at a breakneck speed, faster than expected. I think I read something similar to this in one of the other streams, but a massive crack is widening across Africa, hinting at a transformation deep beneath the surface. Tectonic forces are reshaping the land faster than expected, with signs of an emerging ocean. Scientists are closely monitoring the shift and uncovering clues about what's unfolding beneath our feet. The continent's future is changing, and implications will be enormous. The African continent is undergoing a dramatic transformation as tectonic forces carve a path towards the formation of a new ocean. The East African Rift System, a vast network of faults stretching from Mozambique to the Red Sea, is actively reshaping the landscape. Recent studies have suggested this process, though once thought to span tens of millions of years, could unfold in as little as 1 million years, or maybe even sooner. A continent deep beneath Africa, the African and Somali plates are moving apart at a rate of 0.8 centimeters per year. This slow but persistent shift is tearing through East Africa, creating massive fissures and gradually weakening the landmass. One of the most striking examples of this transformation is in the Afar region of Ethiopia, where a 60 kilometer long rift is already formed, reaching depths of 10 meters. While seemingly small in the human timescale, this marks the beginning of what could be one day be an entirely new ocean, separating parts of East Africa from the rest of the continent. Why am I having problems with the word continent today? We reduced the time frame to about 1 million years, possibly even half that, says Cynthia Inbringer, geoscientist at the Tulane University. This accelerated timeline suggests the rift's progress could be even further sped up by earthquakes or volcanic activity. Events that are difficult to predict, but could have immediate geological consequences. Echoes of the past, the birth of a new ocean. The East African Rift is the only place on the Earth where the continental crust is splitting into ocean crust in real time. This rare opportunity allows scientists to bear witness to the birth of a new ocean basin, a process that once shaped the Atlantic Ocean millions of years ago. In 2005, Ethiopia experienced a geological event that shook researchers. Over 420 earthquakes in just a few weeks triggered the rapid formation of a massive fissure. What typically takes centuries happened in mere days, proving that tectonic shifts are not always slow and steady. How Africa's landscape will change. The formation of new oceans will redraw Africa's map, reshaping not only the land, but its economies, ecosystems, and infrastructure. New coastlines. Landlocked countries like Zimbabwe and Uganda will gain ocean access. Zambia and Uganda. Economic opportunities. This shift could create new trade routes and ports, transforming regional economies. Ecosystem evolution. Emergence of a marine environment will create new habitats, altering biodiversity. You know the way. I know the way. I seem to don't know how to say things correctly, so I don't know the way. Do you pin the... Oh, certain thing. Infrastructure challenges. Nations will need to adapt the rising sea levels, shifting landscapes, and seismic activity. Alright, I just happened to roll down, and we're clicking on this. I blame you. I blame you, Wolf. This was on the article that you suggested. This was below. This was on the article you suggested as a suggested next link post to see. World's first 3D printed penis implant successfully restores function in pigs and rabbits. I would say, the thing is, how could I not? Advancing in 3D bioprinting is taking a new bold step. A team of researchers from China, Japan, and the United States has successfully 3D printed a fully functional penis and implanted it into rabbits and pigs with promising results. This cutting-edge breakthrough in regenerative medicine could transform the treatments for penile malformation, erectile dysfunction, and other sexual disorders. Yeah. Researchers were led by scientists at the South China University of Technology in Yangzhou, China. I'm probably saying that wrong. I probably am, yes. The study represents a collaborative effort between international researchers working on bioengineering, regenerative medicine, and tissue printing. This advancement builds on decades of research into bioprinting of soft tissues for functional organ regeneration. The 3D printing in medicine has already enabled the creation of customized prosthetics and the repair of human tissues, and also basically making a face out of human living, basically growing a living tissue kind of thing. If I remember, we had that in one of the earlier streams. The face looked creepy. However, replicating an entire complex organ like the penis marks a scientific milestone. The research team used an advanced bioprinting technique to construct a penile model using hydrogel, a material that mimics human tissue and supports cell growth and function. I don't know. But this is science, y'all! We aren't being gross. The printed model contains key components of a real penis, including the corpora cavernosa, corpus spingonisum, and the tunica albigina, all critical for achieving erection and sexual function. Apparently, yes! Apparently, yes! Wolf! The Tunisia albigina, in particular, plays a vital role in sustaining an erection. There! And scientists have successfully engineered a synthetic version of this tissue called an artificial Tunica albigina. ATA. Artificial tuna. I know, right? Comprised of polyvinyl alcohol, which mimics the natural tissue's elasticity and structure. Overcoming the biggest challenge, blood flow. This is science. Science. Science is fun. The major hurdle in printing a functional penis was recreating its vascular system, which enables the rapid blood flow, inflow, and erection. Without proper blood circulation, the implant would be useless. To solve this, the scientists incorporated endothelial cells, the cells lining blood vessels, to form a network of functional blood vessels. This vascularized tissue allows the implant to receive adequate blood supply, leading to a functional erection. According to the study, the erection of the penis returned to normal after suturing the ATA at the injured part, and the long-term prognosis was satisfactory. This suggests that synthetic tissue can effectively replace natural penile function and could be applied to human treatments in future. I mean, successful animal trials, erections, and reproduction. To test their innovation, researchers implanted the 3D printed penile structures into Bama miniature pigs and rabbits suffering from penile malformations. The results showed that the animals not only regained erectile function, but were observed mating and reproducing. This success suggests that bioprinted organs could soon offer a real solution for human patients. Specifically, this technology could help treat conditions such as Peyronie's disease, which affects 5% of men between 40 and 70 and leads to painful curved erections due to scar tissue buildup. No, it is not. Which reminds me, I need to plan something for April Fools. 3D bioprinting. The field of 3D bioprinting is advancing rapidly. With emerging technologies such as xerography, a light-based 3D printing method that enables the fabrication of living cellular structures. Scientists are now exploring ways to print entire organs such as kidneys, muscles, and blood vessels, potentially transforming the transplant medicine. The artificial genetic albuminia also holds broader medical potential, as its biomimetic design could be adapted to repair other load-bearing tissues, including blood vessels, intestines, corneas, bladders, tendons, and myocardium, heart tissue. Future of bioengineered sexual health. This 3D breakthrough in 3D printing opens the door for a future where personalized bioengineered implants could restore lost or impaired functions in millions of patients. But with such advancements comes ethical and regulatory challenges, as was the need to research into guaranteed safety and effectiveness. The study published in the Nature Biomedical Engineering signals that the future of regenerative medicine is closer than ever. If human trials prove successful, 3D printed organs should redefine the way we treat congenital disorders, traumatic injuries, and sexual dysfunctions. For now, the success in rabbits and pigs is a thrilling glimpse into what could be medical revolution. Alright. Back to the actual planned subjects. Alright. Truly incredible. Princeton researchers have discovered a new method to reshape the fabric of life. Scientists have used light-activated droplets to reposition DNA, offering a new insight into gene expression and disease treatment. With a flick of light, researchers have discovered a method to reshape the fabric of life, folding DNA strands back onto themselves to reveal the material nature of the genome. Scientists have long debated the physical nature of chromosomes, the structures located deep within cells, made up of long DNA strands tightly wound around millions of proteins. Excuse me, sneezing. Sorry, Sorry. Do they act more like a liquid, a solid, or something between? Much progress in understanding and treating disease depends on the answer. A Princeton team has now developed a way to probe the chromosomes and quantify their mechanical properties. How much force is required to move parts of its chromosome around and how well it snaps back to its original position. 1 second. Stretching. The answer to that material question, according to their findings, is that in some ways that the chromosome acts like an elastic material, and in other ways it acts like a fluid. By leveraging that insight in exacting detail, the team was able to physically manipulate DNA in new and precisely controlled ways. They published their findings in the journal Cell on August 20th. Excuse me. What's happening here is truly incredible, said Cliff Bragenwin, the June KU 92 professor of chemical and biological engineering, director of Princeton's Amin Darling Bioengineering Institute, and principal investigator of the study. Basically, we've turned droplets into little fingers that pluck the genomic strings within living cells. The key to the new method lies in researchers' ability to generate tiny liquid-like droplets within a cell's nucleus. The droplets form like an oil in water and grow larger when exposed to a specific wave of blue light. Because the droplets are initiated at a programmable protein, a modified version of the protein used in the gene editing tool known as CRISPR, they can also attach a droplet to a DNA in precise locations, targeting the genes of interest. With their ability to control this process using light, the team found a way to grow two droplets stuck to different sequences, merge the two droplets together, and finally shrink the resulting droplet, pulling the genes together as the droplet receded. The entire process takes about 10 minutes. Using condensate green, researchers pulled two sections of DNA strands together, enabling them to touch. Physically repositioning DNA in this way represents a completely new direction for engineering cells to improve health and could lead to new treatments for diseases, according to the researchers. For example, they showed that they could pull two distant genes towards each other until the genes touch. Established theory predicts that this could lead to greater control over gene expression or gene regulation, life's most fundamental processes. Material science of our genome. A DNA model is structured like a long double strand. In living cells, the strand is wrapped around a specialized proteins to form a material called chromatin, which in turn coils itself to form structures we know as chromosomes. If uncoiled and stretched end to end, all of a person's chromosomes would measure about 6.5 feet long. So it'd be taller than I am. Sorry. Human cells must fit 23 pairs of these chromosomes, collectively called a genome, in each cell's nucleus. Hence the need for tight coiling. Since DNA is both the carrier of information and a physical molecule, the cell needs to unfurl the tightly coiled parts of the DNA to copy its information and make proteins. The areas along the genome that are more likely to express are less rigid physically and are easier to open up. The areas that are silenced are physically more coiled and compact, therefore harder for the cell to open up and read. Like an instruction manual that opens more easily to some pages than others. Alright, you can make a, the fat bank opens more easily to certain pages than others. Anyways, Amy R. Strom, Yoon Shin Kim, and Cliff Bragwin. You're missing a picture in this, or it could be edited out since I'm using ad blocker. Because fuck if any of these sites would be readable. The research team includes postdoctoral scholar Amy R. Strom and recent graduate PhD Yoon Nish Kim turned into blobs of liquid known as condolences to do the work of bending the DNA strands and moving them around. While subcellular components known to science are like soap bubbles, with a distinct membrane keeping the inside separated from the outside, condolences are liquid-like droplets that fuse together more like raindrops, with no membrane holding them together. After forming and carrying out a cellular function, they can break apart and disperse again. To study chromatin in more detail, Strom and Kim built upon a previous research from Bragwin lab that engineered condensatants from biological molecules in the cell using laser light to create and diffuse droplets together. Fuse droplets together. In this new work, they utilize an additional component that attaches the condensate to specific locations in the DNA strand and direct their movement quickly and precisely via surface tension-mediated forces known as capillary forces, which Princeton researchers had suggested could be ubiquitous in living cells. You know, capillary, when you're doing Subnautica or whatever, not being too loud, getting past monsters in the sub, big sub. Previously, moving DNA like this relied on random interactions over periods of hours or even days. We haven't been able to have this precise control over a nuclear organization. Yeah, I know it's malfunctioning. I need to find... I bought a new... I was going to use this thing until it died, pretty much. And it's dying on me. I bought a new. I just need to remember where I put the new phone. Not phone. The mouse. I know words exist. They're amazing, aren't they? Yes. Do they exist right now in my brain? No! Alright. Like CRISPR, but different. Now they can move the strands around in a controlled way. They can start looking at whether genes in their new positions are expressed differently. This is potentially important for furthering our understandings of the physical mechanism and material science of the gene expression. Strom said that scientists have looked at the stiffness of the nuclei by poking at it from outside and taking a measurement from the whole nucleus. Scientists can also look at one gene and see if it's turned on or off, but the space in between is not so well understood. We can use this technology to build a map of what's going on in there and better understand when things are disorganized, like in cancer, said Strom. This new tool is poised to help researchers understand gene expression better, but it's not intended to edit the DNA. Our tool does not actually cleave the DNA sequences like CRISPR does, said Kim. CRISPR is really good for diseases that are related to the need to cut and actually change the DNA sequence, said Strom. This technology could work for a different class of diseases, especially those related to protein imbalances such as cancer. If we control the amount of expression by repositioning this gene, Strom said, there is a potential future for something like our tool. Alright. Speaking of changing stuff, scientists reprogram immune cells to stop autoimmune attacks. A revolutionary approach to immune therapy has emerged. Engineered immune cells that protect healthy tissues without compromising the body's defenses. This could transform treatments for diabetes, transplants, and cancer. When the immune system becomes unbalanced, it can lead to serious problems, such as type 1 diabetes and other autoimmune diseases, or organ rejection after a transplant. Current treatments often involve suppressing the entire immune system, which can cause severe side effects, including higher risk of infections and other complications. A better approach would be to regulate the immune response in a precise and targeted way. That's exactly what researchers have now achieved by engineering specialized immune cells designed to restore balance without compromising overall immunity. Engineering immune cells to protect rather than attack. The immune system defends the body against viruses, bacteria, and other threats by identifying harmful invaders and mounting responses. I have a weak immune system, so good luck. It also distinguishes between the body's own cells and foreign ones, adjusting its reactions as needed. However, when the immune system becomes dysregulated, it can mistakenly attack the body's own tissues. This happens in conditions like type 1 diabetes, where the immune system destroys insulin-producing beta cells in the pancreas. It can also reject transplant organs, treating them like foreign threats. While immunosuppressant drugs can prevent these harmful reactions, they can come with serious risks, including increased vulnerability to infections and cancer. Now researchers have developed specialized immune cells designed to regulate and calm excessive immune responses. These engineered cells recognize and protect healthy tissues by preventing T killer cells from attacking them. This breakthrough could help stop organ rejection and reduce the need for strong immunosuppressant drugs, offering a safer and more targeted approach to immune regulation. The work was carried out by UC San Francisco with significant contributions from the Mathis Hibrook, professor of applied stem cell and organoid systems at the Technological University of Munich, and Dr. Hassan Mashi, postdoctoral researcher at Tum, and Helmholtz, Munich. The studies were published in this journal of science. This technology could put the immune system back into balance, says Wendell Lim, PhD, UCSF, professor of cellular and modular pharmacology. We see as a potential platform for tackling all types. Okay, tell me how. We get the picture. Okay, reprogramming immune cells for targeted protection. To engineer their regulatory immune cells, the researchers are using the same type of cells as in the CAR T cell immunotherapies. For the latter, they are specifically engineering to target tumor cells. By contrast, the engineered regulatory immune cells are designed to protect healthy cells. They produce a combination of proteins that the researchers have found to be particularly effective for regulation. One has an anti-inflammatory effect, while the other scavenges pro-inflammatory substances. A cell system can be flexibly adapted for different applications. The goal: the safeguarding of beta cells in diabetes. To test the application in type 1 diabetes, researchers modified the cells to recognize and protect human beta cells. They introduced the engineered immune systems to mice and had received a transplant of human islet cells, modeling the treatment for type 1 diabetes. The experiments were successful. The transplanted beta cells were protected by the engineered cells, survived, and continued to produce insulin. In contrast, the transplant cells without the protected engineered T cells were destroyed. A future of precision immune therapies. The authors envision a future which organ transplant patients or those with autoimmune diseases receive therapies that only treat the specific regions of the body where the immune system is misbehaving, instead of shutting down the whole system. The new technology could also be used to fine-tune CAR T cell therapies for cancer, so that CAR T cells only attack tumors and not healthy tissue. Being able to modulate immune responses and further optimize functional properties of stem cell derivative tissues is central to the development of long-lasting stem cell therapies, and is a clear goal of the organoid researchers at the new Center for Organoid Systems at Tome. Okay. Alright. How quick are we going to get through this before Smithsonian kicks me out? Because I have a hit or miss on trying to get the Smithsonian to work. Archaeologists discover a rare clay commander among the thousands of life-size terracotta soldiers in China. The 2,000-year-old military general figurine is the 10th of its kind to be excavated from the Emperor Qing Shi Hong. The name of the emperor that created the terracotta soldiers, but I mean, it's what China's named after. The Qin Dynasty, yeah. Qin Shi Hong, I think. Among the famed terracotta warriors in the sprawling tomb of the ancient Chinese emperor, archaeologists have excavated a rare decorated statue. Judging by the figure's features and location, they think it depicts a high-ranking military officer, only the 10th of its kind ever excavated. The Qinshi was the first leader to unite China under one rule. At more than it's 221 to 210 BCE. At more than 20 square miles, this tomb in China's Shanxi province contains an estimated 8,000 life-size statues of soldiers known as the Terracotta Army. The terracotta warriors are armed with spears, swords, and crossbows, and they were meant to protect the the emperor in the afterlife. While most of the carved figures wear simple armor, a recently discovered figure's armor is colorfully painted and carved with detailed patterns, ribbons, and floral knots, according to the Chinese state-run news site The Global Times. These adornments and high-ranking officers indicate how special they were. I am so sorry. Zhanli, an archaeologist at the University of Oxford, who works at the mausoleum site. The style and color of the ornaments featured the aesthetic taste and status symbol of the time. Do they have pictures of it? No, they don't. I didn't check too much far in there. Roughly thousands clay warriors have been unearthed, but only 10 of these have been military leaders. The recently discovered statue was found alongside the remains of 2 chariots, 3 statues of horses, and 2 other clay figures. Based on its location, we believe this figure was likely the highest-ranking military commander of its unit. But that... I guess his was painted, so... Alright! Will this allow me to see it? I don't wanna... we can see it this way. So this is the first time anybody has seen this that, like, isn't dead, where it's, like, washed up on shore. Because this is an abyssal deep-sea creature. Fish. What may be the world's first ever recorded sighting, a black sea devil anglerfish known for living at thousands of feet beneath the Earth's ocean surface where light no longer touches, was caught on camera swimming close to the ocean's surface. The footage was captured in Spain's Canary Islands. It shows the female fish, whose Latin name translates to black sea monster, swimming through the light-filled oceans off the coast of Tenerife. The discovery was made by NGO Conrad Tenerife and marine life photographer David Jar Bedoya said that while they were researching sharks. Once they got closer, they realized it was said that the fish emerged from the abyss about 1.2 miles off the coast. In Spain. Once they got closer, they realized it was a humpback anglerfish, the type of black sea devil anglerfish similar to what was portrayed in the Disney animated movie Finding Nemo. Its genus and its Latin name is Melancetus johnsoni. Johnsons are now sea monsters. I'm kidding. It could be the first ever sighting of a adult black devil or abyssal anglefish, alive in broad daylight and on the surface. Adding that the recorded to date has similarly only included larvae or dead adults, and the only live viewings have been recorded via submarine, a legendary fish that few people will have the privilege of observing alive. The researchers describe the fish as the true predator of the deep, a characterization which rings true. Black sea devils can live up to 15,000 feet under the ocean's surface, with humpback anglerfish specifically known to live as deep as roughly 6,500 feet under the sea, according to the researchers. Such depths is known as the bathypelagic, or the midnight zone, where animals live in constant darkness and their only light comes from the bioluminescence. Female black sea devils, such as the one that was documented, will attract prey with the fishing rod-like structure on their head that has a tip that lights up in the dark. As demonstrated in Finding Nemo, the prey attracted to the light, and when they get close, the anglerfish can eat them. Female humpback anglerfish are more powerful of the sexes of the species, growing far larger than their male counterparts. They can grow up to be 7 inches and take on the more iconic look with large head and pointed teeth in the bioluminescent lure, while the males only grow to be about 1 inch long and lack a lure, according to Austrian Museum. I'm not sure if they're the type that actually, you know, attach to the female once they find them and never... Researchers aren't sure why this female found her way in such a light-filled and shallow waters. They said it could be because of an illness, updraft, or perhaps fleeing a predator. But what they do know is the observation was surprising. It did not leave the crew indifferent and will be remembered forever, they said. Alright. My voice is starting to go. Paleontologists uncover a record-breaking colossal sea monster skull. Stronger than the T-Rex. A massive fossil skull has been unearthed along the Jurassic coast, revealing a prehistoric predator unlike any seen before. With a strange crest on its head and unmatched bite force, experts believed it dominated the ancient seas. The discovery challenges everything we know about the creatures, hitting in a new species lost to time. A massive fossil skull retrieved from a cliff near Kimmeridge Bay in Dorset, UK, has stunned paleontologists and dinosaur enthusiasts alike. Belonging to a pliosaur, a prehistoric marine reptile, the discovery has reignited the debates about the fiercest predator in the Jurassic seas. With a bite force that could outmatch the legendary Tyrannosaurus rex, this colossal creature once terrorized the ocean. Let's make as much jokes and puns as we can. A jaw-dropping extraction from the cliffs of Dorset. The fossil was embedded approximately 12 meters, or 35 feet up a cliff, along the Jurassic coast, a region renowned for its rich paleontological significance. The extraction was led by expert Chris Moore and collector Steve Etches. Collector's name is Etches. Okay. From both of whom have dedicated their careers to unearthing Jurassic fossils. Etches, the founders of the Etches collection in Kimmeridge, immediately recognized that this find was different from the previous Paleosaur fossils. One particular feature, a distinctive cranial crest, has never been seen in any other known species, hinting it might have been an entirely different new species. Other known specimen, excuse me. Additionally, the jawline extends to the back of the eye, unlike other plesiosaurs, where it typically stops at the front. The anatomical differences have intrigued paleontologists who are now studying the fossil for further classification. A sea monster with a stronger bite than a T-Rex. Pliosaurs, like the one uncovered in Dorset, were apex predators of the Jurassic oceans, with immense muscular jaws and razor-sharp teeth designed to crush prey with devastating efficiency. Scientists studying the fossil believe that its bite force was even greater than that of the Tyrannosaurus rex, meaning that in a hypothetical battle, the marine reptile could have come out victorious. Renowned naturalist David Attenborough, who followed the discovery, even asked experts about such a matchup. The response? A decisive win for the pliosaur. I'm gonna keep saying it different ways every single goddamn time. It was the most terrifying animal in the seas, said Dr. Andre Rao, an American expert consultant did during the research. Well, also the small fact is, it will be in the fucking ocean to try and get it, unless they're like... So, the disadvantage of the T-Rex being in the ocean, or in water... Yeah. A near-perfect skull and a once-in-a-lifetime find. Fossil skulls of this caliber are incredibly rare, especially in such pristine condition. According to the experts, the preservation of the skull, found exactly as it was in life, is a once-in-a-billion discovery. Edinburgh, who observed the skull firsthand, remarked, "The first thing that struck me was the sheer scale. The skull is enormous, and its level of detail is breathtaking." Additionally, the fossils feature sensory pits and possible parietal eye, a primitive eye-like structure on the top of its head. This adaptation could have helped the plesiosaur navigate its environment, much like the crocodile's ability to sense changes in the water pressure. The story captured on film. The entire fossil recovery process has been documented by the BBC, and a special program are airing on BBC One and iPlayer. Edinburgh himself narrates, of course he does, documentary offering viewers a front row seat. One of the most significant prehistoric discoveries in the recent years. The skull is now hosted at the Etches collection. Further research will determine whether it's truly a new species of plesiosaur or yet another chapter of Jurassic Coast's legendary fossil legacy. Alright, this is pulled up purely for Apocalypse's sake. Exploring the neural correlations of dream phenomenology and altered states of consciousness during sleep. Alright. Okay, let me see what the lucid dreaming... Was this the one that... Is that the one that I might have pulled out the wrong one. Yeah, I think I pulled out the wrong one. Oops. Alright. Yes, sorry about... Anyways, violence leaves its marks on our genes for generations, studies find. A stressful life can leave marks on our genetic code, some of which can be even passed on to our children. A study now reveals how biological impact of trauma on a mother persists long after the violent acts themselves have passed. The international team of researchers demonstrated the physical mechanisms behind intergenerational trauma in humans, explaining why people with a family history of adversity are more prone to mental health conditions like anxiety and depression, despite not having experienced the adverse effects themselves. Researchers analyzed DNA collected from 48 Syrian families across 3 generations. These families included grandmothers or mothers while pregnant who had fled during the 1982 siege and massacre in Hama, or the 2011 armed uprising, both part of the ongoing Syrian civil war. Working closely with these families who now live in Jordan, the researchers were able to collect cheek swabs from 131 individuals, which were analyzed for shifts in epigenetic signatures. These aren't changes in the DNA sequence itself, but chemical alterations that affects how sequences function. The families want their story told, said University of Florida anthropologist Connie Milligan. Using the families who left Syria prior to the 1980s as controls, the team found that the modifications in 14 genome areas related to violence in individuals whose grandmothers were involved in the 1982 Hama attack. What's more, 8 of those modifications persisted through to the grandchildren who had not experienced the violence directly. The results also indicated an accelerated epigenetic aging, potentially increasing the risk of age-related disease. In addition, another 21 genome areas showed signs of alteration caused directly by violence in the Syrian civil war. These changes were observed by the researchers were consistent across victims of violence and their descendants, suggesting that it was the stress of the conflicts that had changed the chemical messaging associated with these genes. These kinds of long lasting multi generational gene changes in response to stress have been previously observed in animals, but until now there's been little research on how this may also work in humans. What isn't clear from the study is how these modifications might impact each individual's health. The researchers say they came away with lasting impression of the perseverance of these families. In the midst of all this violence, we can still celebrate their extraordinary resilience, said Milligan. They are living fulfilling, productive lives, having kids and carrying on traditions. They have persevered. That resilience and perseverance is quite possibly a uniquely human trait. I doubt that on not human trait. Life will find a way, human or not. Of course, there are many more destructive consequences of violence for the victims and their children, including significant harms to mental health and physical health covered by previous studies, which aren't quickly forgotten. According to the researchers, these findings are likely to apply across many forms of violence, including domestic violence, sexual violence, and gun violence. These acts have long-lasting effects far beyond those involved. The idea that trauma and violence can have repercussions into the future generations should help people be more empathetic, help policymakers pay more attention to the problem of violence, says Mulligan. It could even help explain some of the seemingly unbreakable intergenerational cycles of abuse and poverty and trauma that we see around the world, including the US. And the last one for tonight, tinnitus. As somebody who has tinnitus, which is probably why my audio in this stuff isn't always the best, because I don't really realize it. Around 15% of the world's population suffers from tinnitus. Tendinitis. A condition which causes people to hear sounds such as a ringing or buzzing without any external source. It's often associated with hearing loss. I've had it as long as I can remember. I didn't realize people normally didn't have it until somebody it was in middle school, I think, that they were telling us a whole infomercial about why we should keep ourselves safe from like having our earphones up too loud or standing next to loud speakers and stuff. The whatever person on the infomercial, well, it wasn't an infomercial, but it was a children's show, whatever, got it, and was talking about suddenly having ringing in their ears, and I was like, what, people don't normally have that in there? Not only can the condition be annoying for sufferers, but it can also have a serious effect on mental health, often causing stress or depression. This is especially cause for patients suffering from tendinitis over years and months or years. There's currently no cure for tendinitis, so finding a way to better manage or treat can help many millions of people worldwide. One area of research that may help us better understand tinnitus is sleep. There are many reasons for this. First, tendinitis is a phantom percept. This is when our brain activity makes us see, hear, or smell things that aren't there. Most people only experience phantom perceptions when they're asleep. But for people with tendinitis, they hear phantom sounds while they're awake. The second reason is because tendinitis alters brain activity, with certain areas of the brain, such as those involved with hearing, potentially being more active than they should be. This also may explain how the phantom percepts happen. When we sleep, activity in the same brain areas also changes. Our recent research review has identified a couple of brain mechanisms that underlie both tendinitis and sleep. Better understand these mechanisms and a way the two are connected could one day help us find ways to managing and treating tendinitis. When we fall asleep, our body experiences multiple stages of sleep. One of the most important stages of sleep is slow wave sleep, also known as deep sleep, which is thought to be the most restful stage of sleep. During slow wave sleep, brain activity moves in distinctive ways through different areas of the brain, activating large areas together, such as those involved with memory and processing sounds, before moving on to others. It is thought that slow wave sleep allows the brain's neurons, specialized brain cells which send and receive information, to recover from daily wear and tear, also helping sleep make us feel rested. It's also thought to be important for our memory. Not every area of the brain experiences the same amount of slow wave activity. The most pronounced in areas where we use most while awake, such as those important for motor function and sight. But sometimes, in certain areas of the brain, can be overactive during slow wave sleep. This is what happens in sleep disorders such as sleepwalking. A similar thing may be happening with people with tendinitis. We know that hyperactive brain regions may stay awake in an otherwise sleeping brain. This would explain why many people with tendinitis experience disturbed sleep and night terrors more often than people that don't have tendinitis. Tendinitis patients also spend more time in light sleep. Simply put, we believe that tendinitis keeps the brain from producing the slow wave activity needed to have a deep sleep, resulting in light interrupted sleep. But even though tendinitis patients have less deep sleep than on average than people without tinnitus, the research we looked at in our review suggests that some deep sleep is hardly affected by tinnitus. This may be because the brain activity that happens during the deepest sleep might actually suppress it. There are a couple of ways the brain might be able to suppress it during deep sleep. The first has to do with the brain's neurons. After a long period of wakefulness in the brain, are thought to switch to a slow wave activity mode to recover. The more neurons in this mode together, the stronger the drive for the rest of the brain to join. We know that the drive for the sleep can also get strong enough that the neurons in the brain will eventually go into slow wave activity mode. And since this especially applies to brain regions overactive during wakefulness, we think that tendinitis might be suppressed as a result of that. Slow wave activity is also shown to interfere with communication between brain areas. During deepest sleep, when slow wave activity is strongest, this may keep the hyperactive regions from disturbing the other brain areas and from interrupting sleep. So it'd be why people with tendinitis may still enter deep sleep and why it may be suppressed during that time. Sleep is also important for strengthening our memory by helping to drive changes in connections between neurons in the brain. We believe that changes in the brain connectivity during sleep are contributing to what makes tendinitis last for a long time after initial trigger, such as hearing loss. We already know that the intensity of tendinitis can change throughout any given day. Sorry, my voice is going. Investigating how tendinitis changes during sleep could give us a direct handle on what brain does to cause fluctuations in tendinitis intensity. It also means we may be able to manipulate sleep to improve the well-being of patients and possibly develop new treatments for tendinitis. For example, sleep disruptions can be reduced and slow wave activity can be boosted through sleep restriction paradigms. I had to think about how to say that. While patients are told only to go to bed when they're actually tired, boosting the intensity of sleep could help us better see if the effects of sleep has on tendinitis. While we suspect that deep sleep is most likely to affect tendinitis, there are many other stages of sleep that happen, such as rapid eye movement or REM sleep, each with unique patterns of brain activity. In future research, both sleep stage and tendinitis activity could track at the same time by recording brain activity. This may help us find out more about the link between tendinitis and sleep and understanding how tendinitis may be alleviated by natural brain activity. Well, that's it for tonight. I'm trying to do this rating. Alright. Anyways, Well, that's the end of our stream. I need to find a better outro on that. But my voice is going. Let's find somebody to rate. The last one? Yeah, I wish I could get rid of tinnitus. Help me, please. Is Mist still on? Y'all still playing whatchamacallit? The Fatal Frame 2? Oh, that's okay. I wasn't sure. I'm just gonna end the stream. So many people are playing games that I don't want spoilers on. It's not funny. Ah. All right, y'all. This is Ishnai Ciarfox. I hope you have a good day or night, whenever it is, wherever it is you currently are. If you're watching this on YouTube, please like, subscribe, and comment. All right, night, y'all.